All right, this will be the last video for lesson 2, or for section 2. This is lesson 2.5, linear relations. Term for this would be linear regression. And so what this is doing is it's taking the concepts that we learned about linear functions and it's going to put them into like real life situations and talk about how we can use linear relationships to describe real life situations. So it's going to deal with this idea of correlation. So in real life, when we look at data, it doesn't just fall in a straight line like our normal linear functions do. The information is going to be scattered. It's not going to be just in a perfect straight line. However, we can see in these images that there are trends. This is what we call positive correlation. This is negative correlation. This is no correlation because those dots are just kind of scattered everywhere. So we have a way of taking this information and deciding what we think the best kind of version of that would be if we were to make a line. And so we're going to do that using the Desmos system. I'm going to scroll down here and go to the first part. So it says here, use your graphing calculator to determine the coefficient of correlation. So it's saying, what does this data look like in terms of this? Make the points on the graph and then find the line that works best to fit them. So on Desmos, I'm going to click over here. From your main screen, you're going to click the hamburger menu up here at the top where it says Open Graph. And then you're going to scroll down into the example menu, and you're going to go all the way down until you see Statistics, Linear Regression. And then you're going to open that graph for linear regression. It's going to have an example already graphed for you. So you can see what it's going to do. It's going to graph the points, and then it's going to find that line for you. So we're going to go here, and we're going to delete all of our information out of here. Now let me go here, delete. Okay. And so we're going to enter the information that we have from this 1, 2, 3, 4, 5 into X. So 1, 2, 3, 4, 5. And in between each of those, I'm just hitting enter to move to the next line. Then I go to my Y, and I have 3, 5, 6, 2, 4. 3, 5, 6, 2, 4. Okay, so it's already done the work for us. We have our green dots. We have this orange line running through the middle. It's the line that best fits this information. And then it gives us some statistics right here. It has R squared, R, M, and B. So M and B are our slope and y-intercept of this orange line. And so that's the first thing we want to look at. So I'm going to jump back over to our answer. And this is asking for the linear regression. And the first thing you're going to put every single time, and you're going to use AX plus B. That's just the form of the equation. Now, on our map, on our graph, it did mx plus b, but we're going to do a because actually most calculators use a when they're doing this. But our a value is going to be our m value right here. So our a is negative 0.1. Our b value is 4.3. And our R value is negative 0.1. And that's all you have to do. Once you enter the data, you just have to identify the M, which is the A, the B, and the R value. Now we're going to go to the next question because it actually asks us, what's the best equation for the line? Well, we should know that if we're doing M and B, M is the slope, B is the y-intercept, so it's going to be mx plus b. So m is 0.1. So m should be negative 0.1 x plus b, which is 4.3. So then this is the answer choice. All I'm doing there is I'm taking this a and the b, and I'm putting it in a and b here so that it makes an equation. Now I'm going to go to my next one. So now we have to enter this data into the linear graph. So we're going to jump back over here. I'm going to get rid of my data from my previous problem. And we're going to get rid of all that. All right, then I'm going to type in my x's, which is going to be the temperature. 76 84, 88, 72, 84, 98, and 76. And I go to my next one. 74, 73, 86, 67, 79, 93, 75. Okay, so I'm just entering X values, Y values. Oops, sorry about that. Y values. All right, now we're going to run. We already did it automatically. It automatically did this for us. Whoa, sorry, jump down the screen there. Let me go back up. Okay, and we're going to go here, and we're going to look down here, and we see that we have our line. Now, where do my points go? Well, since these values are 70, 80, 90, they're way up here. You're going to zoom out. You can zoom out by clicking here. So let's zoom all the way out here. And now we can see there's my dots, there's my line. So this is a lot closer to what we want to see here. So in other words, the points are very close to the line. So let's go down. Okay, so I have M of 0.9184. Okay, so let's go look at our M. First, AX plus B. And then 0.9184, okay? Well, there's no 9.1, but there's 9.2, which is rounded up. So let's click that one. We go to our B. The B is 2.3. There's 2.3. And then 0.9273, which should be rounded up to 0.93. All right, so there's my answers there. Also, question, A and B, 9.2, 2.3. There it is, 0.92x and 2.3. That's my answer choice for the graph. And then it has another question here where it wants us to look at the, there we go, the correlation coefficient. We already found that. The correlation coefficient was 0.9273. So that's rounded up 0.93. I don't know why they asked that a second time, but they do. And then lastly, it says this. Nope, not lastly. There's one more. Is the correlation weak, strong, or very strong? Well, this is very close. These points, some of them are nearly touching the line. They're all along the same path. So we're going to say anything above 0.9. So here, anything above 0.9 is going to be considered very strong. Anything between 0.5 and 0.9 is just going to be strong, and then below there you get weak and then very weak. All right, now it says, use the regression equation. How much would Felicia expect to pay for electricity if the mean temperature for the month is 102? So in other words, if we put a 102 here, what would I think the graph would give me? So I can actually do that. If you see here, I have 100, and then this would be 102 right here. So 102 is going to be, let me zoom in. There we go. 101, 102. It looks like 102 is about 96. So you see how I'm hovering, and I can see that there's a 102, and it's like around 96 when I'm at 102. Another way to do that is to type x equals 102, and you'll get a good estimate. So it's just about 96. So we'll look, and all I'm doing there is looking at this point where the 102 crosses my orange line. And so 95 seems too low, so let's pick 96.14 as our answer. And that's it for lesson 2.5. And I'll begin the next unit now.